So this page we're going to emphasize what we have for permutations. In permutations, you're ordering objects. That's what a permutation is the order of objects. But what I really want to draw attention to is these have to be distinct objects. So for instance, A, B, C, and D, there's no repetition, so these are distinct objects. But look at these symbols right here. You have a square, a star, a circle, and a star. We can't do permutations of those because there's repetitions of objects. So the whole point is, with permutations, there's no repetition. Very, very important for you to see. What the next part's discussing is what if you had 3 songs and you could play those songs in any order. So they chose 3 different songs, a rock song, a reggae song, and a country song. There's 3 objects, so there should be 3 factorial ways of doing it. Or you could have looked at it as 3 blanks. You have 3 songs for the first, 2 choices for the second, 1 for the third, which is a total of 6 different ways. So what they did in this next chart is they showed you the 6 different ways you could play a rock, reggae, and country song. Again, there's 2 separate questions. How many total are there versus what are they? So one of them gives you just the total number of options, and one of them gives you all the options. This chart gives us all the options. So, in general, if there are n songs to play, there are n factorial permutations to play them. So that's what this sentence says right here. There's n songs, you have n factorial ways that you can play them. Again, no repetition is allowed on these songs right here. But what if we had, for instance, 8 songs that we wanted to play, but we only have time to listen to 3 of them? How would that work? Well, if we think about the blanks that we had in the boxes, what we could do is look at our 3 different boxes. I have 3 songs. I'd have 8 choices for the first, 7 for the second song, 6 choices for the third. So what this looks like is it's starting 8 factorial, but it doesn't go all the way down to 1. It has to stop after 3 songs. So what if I have, my total is 8 songs, and I want only 3 of them, want to play only 3 of them? What would that look like? How could I do that mathematically? And that's where permutation notation comes in. Permutation notation is the next part right here. There's many different ways of writing it. Our book writes it as P of n comma k, and I want to emphasize what each one of these things stand for. N here is the number of objects, the total number, and k here is what you want. So using this notation, considering the previous problem, we had 8 songs that we had to choose from, and we only wanted to play 3 of them. So what does this mathematically say it would be? It says it's the total factorial, 8 factorial over, and then in parentheses you would do the 8 minus 3 factorial. Let's think about what that is. That's the same thing as 8 factorial over 5 factorial. And let's see what would happen if we expanded that out to see if they're getting the same thing that we would have. This would have been 8 times 7 times 6 times 5 all the way down, so I'm just going to write a 5 factorial. And on bottom we have the 5 factorial, which is 5 times 4 times 3 times 2 times 1. Notice those, because it's multiplication, we could simplify those factorials, and we would be left with 8 times 7 times 6, which is exactly what we were getting above. So this notation, this permutation notation, is an easier way of figuring out if I have order matters, there's no repetition, I have 8 objects, but I'm not arranging all 8 of them. I only want to arrange some subset of them. That's when we would use permutation notation. Again, I want to show you many different ways I could write this. One way the book uses would be P83. You might see me write it as 8P3 or even 8NPR3. These are all the same notation. They all mean the exact same thing. They just look a little different. But what that is I have 8 objects and I want to arrange 3 of them. I will let you guys know, a lot of teachers have you expand these out by hand and show this mathematically by hand. I am not going to have you do this by hand. I am going to have you do it on your calculator. The key things to this that I want you to note, if you're going to use the notation, 2 things. First thing is order matters. The second thing that I want you to write down is no repetition. Those are the 2 requirements for permutations. Order matters, no repetitions. And it is always going to be the total number or the bigger number first, and the smaller number or the number you want second.